Everybody, we talked a little bit about circumference and area in class, and now we're going to use that to talk about the lengths of arcs and the areas of sectors of a circle. So first of all, the length of an arc is just a fraction of the circumference of a circle. The circumference of a circle always is some sort of linear measure, and what I mean by that is if we could cut the circle and lay it out flat, we could measure it with a ruler. So we would measure it in inches or centimeters or feet or miles or meters. So the length of an arc is actually a piece of that entire circumference. So we have a formula that we can use to find the length of an arc, and it's really just the circumference formula multiplied by some fraction of the circumference. So arc length and measure are different. Measure is a degree. Length is a linear measure, like I said, like inches, feet, centimeters. So if we know the degree of the arc, so the number of degrees, which we can get from the central angle, so we'll call that x degrees. So this is x degrees. If we know the degree measure of the arc, we can plug it in there, and we can find out the fraction of the circle that that arc represents by dividing that arc measure by 360. And that'll tell us the percentage of the circle we're talking about, so then we can just multiply using the circumference formula. So we would just need to also know the radius of the circle. So we're going to leave our answers in terms of pi sometimes, and what that means is instead of multiplying by pi or by 3.14, we're just going to leave the pi symbol there and not multiply by it. So in order to find the length of arc xy, we're first going to start with the formula, like always, and we're looking for the length of that arc. So our central angle here is 90 degrees. That means that our arc has a measure of 90 degrees. So we can plug that in for the measure of xy. In this example, we're told the diameter. This tells us the entire length of this segment, which is the diameter. So half of that is our radius. We can plug in here, which is 8. And now we just have some simplifying to do. 90 over 360 is 0.25. 2 times 8 gives us 16. We're going to multiply the 0.25 times 16 to get 4. And then to leave in terms of pi, we just don't multiply by pi. We write it at the end for pi. And of course, we need some units there. This is in inches, so our arc is 4 pi inches long. And you can see here, this was our circumference that we found. The entire circle is 16 pi around. So pause. Find the length of xy in this example in terms of pi. So as always, we start with the formula, and in this case, the degree measure of our arc that we're talking about is 120 degrees, and the radius is given to us this time. It's 15. 120 over 360 is 1/3. It's 0.3 repeating. 2 times 50 gives us 30. So instead of rounding the 0.3 repeating to just 0.3, you should do 120 divided by 360 in your calculator and then multiply that answer by 30. So that'll tell you that we have a arc length of 10 pi, and centimeters is our units. Again, right here, our whole circumference for the circle is 30 pi centimeters. The fraction we're talking about is 10 pi centimeters. So a sector of a circle is very similar to the idea of an arc length. We have a whole area of a circle, and that's all the space inside the circle. A sector is just a piece of that. So example here in red, this area in red is just a part of the entire circle, so a piece of the pie or a piece of the pizza. and we call those things sectors. The formula for the area of a sector is very similar to that of the arc length, but instead we're multiplying our arc measure over 360 by the area formula. So again, we need the arc measure and we need the radius. So I'm using my same example from before. Our central angle is 90, it's a right angle, so that means that our arc measure is 90. We write our formula for an area of a sector. The measure of arc xy is 90. The radius again is 8. So we're doing some simplifying here. And in the end, we get that the area of the circle is 16 pi. And area, remember, is our units are squared, so we have 16 pi inches squared. So pause here, find the area of the green sector in terms of pi. So we start, as always, with our formula. Our arc measure is 120 degrees. Our radius is 15 again. So we plug those values in and do some simplifying. Again, do the 120 divided by 360 and then multiply it by 225. And you'll get 75 pi centimeters square for our sector. And you might notice that the area of our circle was 225 pi centimeters square, and our sector is smaller than that, which it should be, 75 pi. So try both of these problems. They're the same circle, but in one we're looking for the arc length, the other we're looking for the area of that green sector, and leave your answers in terms of pi.